All right, we're back, and we're looking at single replacement reactions. For the single replacement reactions today, we're going to be looking at reactions with water and acid primarily, and then a couple of nitrate solutions. So be sure to read through the procedure so you understand what's going on and the safety information. This builds on the reactions we've looked at so far, and with single replacement reactions, again, we're looking for one thing to switch places in a reaction. We're going to be using a well plate primarily for this one, just so we can see the differences kind of all together. So, oh, no, sorry. Geez, we're going to have to use a test tube. I'm now looking at the procedure. So for the first reaction, we're going to be looking at calcium and water. Tap water is fine for this, just because we're not too worried about contamination. We're not really analytically looking at anything. But we do have to be aware of the tests that are required from the experiment. So we're going to use 2 test tubes, so that way we can test the gas, and we will need a Bunsen burner running to perform our gas tests. Using 2 test tubes of the same size will allow us to collect any gas that's generated. I'm using the ring stand just to keep it nice and secure so I don't have to worry too much. Doing this by myself. We might have Stravinsky pop back in here in a minute to help me. Okay, calcium metal. We've done reactions similar to this before. Gonna take a couple good sized chunks, get them down in there. Not just for ease of process, I'm gonna use distilled water just to make it a little bit easier here. All right, that's definitely reacting. So you need to describe this reaction. And we're going to take a flaming splint. Oh, why is my splint so short? And we'll see if we can get any reaction out of that. Nothing. Let's give it another shot. I may have lost my product. No? Huh. Starting to slow down a little bit. And I'm running out of splint. There it was. Finally. Gosh, my splint was just about done too. All right, we'll take that off there. Important to note that it is still reacting and fizzing and actually quite hot. You might have noticed that there was some condensation that happened. It was actually boiling the water in there, which I think was what was making it kind of difficult to get an accurate reading out of that. All right, we're going to follow that up with aluminum. Here's your aluminum. Get this test tube securely mounted here. We will need the Bunsen burner again for the similar testing. Oh, lost one. There we go. All right, using about the same amount, hopefully. Again, these are all kind of eyeballed. Set that aside. All right, get a little water in there. You probably noticed a stark difference between the last reaction and this one. Don't see any generation of bubbles, any heat or anything of that nature. And we'll take our flaming splint just to check, and it goes out. So indication of nothing really happening there, which might not be too surprising, knowing what they use aluminum for. Commonly used, for beverages in cans. All right, moving along, we're gonna use some zinc, I think. All right, we're using zinc, and it's granulated, they call it. Granulated meaning that it's ground down. I'm gonna try to use similar amounts to the other ones. This one is a little bit different because we will be testing it with hydrochloric acid. Take a look at that. But we will also need the Bunsen burner to light our splint. All right, the hydrochloric acid we're using is, oops, I think it's supposed to actually be 3 molar. There we go. We're gonna use 3 molar hydrochloric acid for this one. And we'll cover the top of it with another test tube. Probably see very fine bubbles coming out of the zinc there. We'll let that run for a little while, collect the result in the top, and then we'll use this splint to test it to see what kind of products we've created. After a minute or so, we're going to use our flaming splint to test that, just as we did in the other ones. Let's give it a shot. Oop, I don't know if you heard that faint popping noise, but we did have a pop in the lower test tube. You can see it's definitely fizzing, breaking all apart. Yep, it's warm too. So definitely a chemical reaction happening there. All right, moving ahead, we're going to do the same reaction with magnesium and phosphoric acid. Here's your magnesium. I'm going to put a couple chunks in there. And we'll add the phosphoric acid. A couple squirts of that. A couple, 3. Try to get the same volume we had earlier with the hydrochloric. And we got to invert our test tube over the top of that. Let's take a closer look at that. All right, we'll get a splint ready. Hopefully we get something that we collected here. Let's see. Oh, that was a good bark. And we had a little pop on the bottom even. Might be able to collect a second round for that one. It's still reacting pretty quickly. And it is warm as well. All right, let's try it again. Oh, a little cute bark. So we definitely have a reaction going on there with that one. Oops, wrong one. we'll set that off to the side. All right, and lastly, we have, two more. We have zinc and lead nitrate. So we're going to bring the zinc back. About the same amount we used earlier. This time we're using lead nitrate. Lead 2 nitrate. That's a solution. Let's see if the lead is reactive enough to switch places. Absolutely. This one's more of an observational kind of thing. If you read the procedure, it says to polish the zinc. We don't have to do that because it's granulated. But hopefully you can see the difference there between the two levels. Let's see if we can agitate that. Oh yeah, we've pretty much reacted all that now. Yeah, we've gotten almost to the bottom. Still got a couple granulated chunks down there, but most of them have had a substantial color change there. That's indicative of a chemical reaction. Got a couple weird open chunks in there. And this we have to put into a heavy waste container because of the lead. Lead is not good for the environment, so we'll save that off to the side so we don't end up with it down the drain or anything like that. Okay, we're going to do a very similar reaction with the zinc, same zinc, but this time with magnesium nitrate. So the lead material was reactive enough to have a reaction occur. Let's see if we can get the magnesium to switch places with the zinc. Again, magnesium nitrate is just a solution, much like the one we just used for the lead nitrate. Look the same to the eye. We'll add a couple squirts in there like that. Take a closer look at it. No color change, heat, gas, or anything created from that interaction. So that concludes all of the single replacement reaction examples. Make sure you write down your observational data in the packet and try to make a prediction for each one of those reactions. And we'll talk about those reactions in more detail later. Thanks.